Okay, let us geometric proof of curvature. What is the meaning of actually? In geometrically, it is I can say that the curvature is reciprocal of radius of osculating circle. We can say that. What is this actually? Osculating circle and all those things. Let us understand here. Suppose we have a curve here, just a curve PQ, and we move from this. What happens? Actually, curvature means as a we. What is the change in the tangential direction as we move from along the curve? Very minute change at a point means at that particular point. What is the amount of change in the tangential direction per unit change in the distance traveled along the curve at that particular point? For that, what we have to measure, for that we have to measure the change in the tangential direction whenever q moves to the just adjacent to that one. What is the change in the tangential direction? And if you divide that change in the tangential direction by that minute change in the distance, we can get the change in the curvature at that particular point. What it indicates? Curvature, the amount of bending of the curve at that particular point it indicates. For that matter, try to understand what we are measuring the curvature at a point, but we are measuring what we are going to q tends to p. What is the change in the tangential direction? And if you are going to divide that minute change in the tangential direction by that qp distance, we can get the curvature. That is what we want here. But what happens whenever q tends to p here? The part of the curve becomes, I can say that, part of the circle. What I want to say is that, see here, whenever q tends to p, whatever this arc curve, part of the curve becomes part of the circle. That is called, that circle which approximates the part of the curve, that is called osculating circle. See, we want to measure the amount of change in the tangential direction. What is this? Means what? If you suppose we have a curve here, if you draw tangent at P and Q, what the tangent at P makes an angle with x-axis, and what is the tangent at Q makes an with an x-axis. If you difference of those things, that is called amount of change in the tangential direction. The difference in the tangential direction, if you divide that difference in the tangential direction by delta s whenever q tends to p, that is we want. But actually what happens, if whenever q tends to p, the change in the tangential direction becomes the angle subtended by that arc at the center of osculating circle. That is that is actually happening here. Why? Because whenever q tends to p, that becomes part of the curve, becomes part of the circle. Then with the center case the radius, and this radius makes an angle delta theta. Because whenever initially it makes an angle, p makes an angle with the x-axis theta, and q makes an angle theta plus delta theta. The difference is delta theta. Okay. Now whenever q tends to p, we can say that this becomes the part of the curve becomes part of the circle. We can get a osculating circle. What happens to the change in the tangential direction? You dot tangent at p and q, you have to measure the change in the tangential direction. For that matter, we need to measure what happens in the, okay, we consider a triangle cpq. Whenever q tends to p, it becomes part of the circle, and we consider the this triangle cpq. We have this angle is delta theta. Because of the r same, the radius c is same, we can get the cpq is becomes the sum of triangles property 180 minus this is delta theta by 2, and this is delta theta by 2. 180 minus that delta theta by, means what? they are equal, these angles are equal, we can say that CPQ is 180 minus delta theta by 2, that is equal to CPQ is equal to 90 minus theta by 2. Keep in mind what we are doing, we are going to measuring the amount of change in the tangential direction whenever PQ tends to P. Therefore, we need to measure the amount in the change in the tangential direction. For that, again, if you draw tangent, the tangent will going to meet at T, and these tangents intersect at T, then angle between this radius and tangent is always 90 degree. We know that. Whenever draw tangent at the P and Q, this is the radius of the osculating circle. That the radius angle between the radius and tangent is 90 degree, so that we know this angle is 90 minus delta theta by 2, and this entire angle is 90 degree, and 90 minus delta theta by 2 becomes what? This becomes delta theta by 2, and this angle also delta theta by 2, because again we want to measure TPQ and TQP, they become delta theta by 2. Actually, now we want to measure the change in the tangential direction. This angle we want, actually, this angle is equal to, according to the sum of opposite interior angles, this angle is equal to sum of these delta theta by 2 and delta, that is called delta psi. Okay, the change in the tangential direction is delta psi, which is given by delta theta. Now we conclude that delta psi is equal to delta theta. Why? Because whenever Q tends to P, what happens? Whatever the Q tends to P, the change in the tangential direction equal to the, which is equal to the angle subtended by the part of the curve arc PQ of at the center of osculating circle. This equal to the change in the tangential direction equal to the delta theta. What is delta theta? Is the angle subtended at the center of the osculating circle by that arc PQ here. Therefore, as Q tends to P, the curvature we already know, we want to find out delta psi by delta S as Q tends to P, that is equal to limit of delta psi by delta S. Now here, I already told you this delta psi is nothing but we already know the property of the circle delta theta, delta S is equal to R theta. Here delta S is equal to R into delta theta, where R is the radius of the osculating circle. Instead of delta psi, or instead of delta S, we can replace delta S by is equal to R into delta psi. Delta S is equal to, if you replace this delta S by R into delta psi, then delta psi get cancelled, we can get 1 upon R. What we can say, 1 upon R is nothing but the reciprocal of radius of osculating circle. This is how we can understand why this curvature at a point is equal to the reciprocal of the radius of osculating circle. Because whenever Q tends to P, whatever the change in the tangential direction, which becomes equal to the, I can say that the angle subtended at the center of the circle by that arc of osculating circle. See, as Q tends to P, the part of the curve becomes a part of the circle, that is called, circle is called, I can say that whenever Q tends to P, just it becomes approximate, best approximate to the and some circle, and the change in the tangential direction is equal to the center of angle subtended at that by arc. Now based on the some property of the circle, whatever the delta psi becomes delta theta, because we want actually delta psi, the amount of the bending of the curve, that will give given by delta psi, and this is equal to the delta theta. Therefore, by that theorem, we can replace delta psi by delta s into 1 upon r. Delta psi get cancelled, we go to 1 upon r. Therefore, we can say that curvature is exactly reciprocal of the radius of the osculating circle. See here in the circle, already told you definition of curvature is delta theta by delta s, and always constant here, because in the circle we curvature is every point we can get same curvature, amount of bending is same throughout all the circle. Therefore we can say that curvature is constant, because to take any point the osculating circle, but in a curve you can get different osculating circles. At every point you can get a different osculating circle, but on the curve, other than the circle, on a curve we can get different osculating, but a circle we can get same osculating circle. That is only one osculating circle is there, that is circle itself. We can get the radius is same throughout the, I can say that any point the curvature is same because the radius is same throughout that. But in case of the curve which is not a circle, what happens, the curvature, what happens in any other than the circle, if you take it a point here you can get different oscillating circle, if you take another point you can get different oscillating circles. As we different osculating circle means you can get uh, the radii going to different. Once the radius is different, definitely since the curvature at that particular point is reciprocal of the radius of osculating circle, therefore the, I can say that the curvature is going to different in case of curve. This is how we can understand. Thank you.